All right, kids, let's keep doing some math because that's why we're here. Last video we talked about x to the 1/2, x to the 1/3, and just fraction powers. It wasn't all we talked about, but it was one of those things. Remember, x to the 1/2 means the square root of x, and x to the 1/3 means the cube root of x, or the third root of x. And x to the a over b is the general way to show b, the b root of x to the a. Okay, that was in our last video. In this video, we're going to do negative powers, negative 1/2, negative 1/3, negative a over b, as well as talk about how to multiply radicals and do some simplifying. So this chapter is all about radicals and rational exponents, which turns out are the same thing. Okay, fraction powers are the same as radicals like x square root and cube root. Now, when you hear complaints about math, frequently students say, or people, even adults, say things like, I didn't like math once we started having fractions. Or I didn't like math once all the numbers went away and it all became letters. And now we have letters with fractions with negatives. And for some of you, that might be just like the trifecta of pain, right? Just like the sets of things you don't want to deal with. But frankly, at this point, we're at a position where negative numbers aren't that big a deal. Fractions aren't that big a deal. Sure, they take some thinking. They take some extra steps. But we can handle them, okay? So stick with me. We can handle this. We're going to be okay. Let's review the properties of exponents real quick. If you have x to the a times x to the b, the powers add. So for example, if I had x squared times x to the third, that would become x to the fifth. If I have x to the a to the b, the powers multiply, a times b. So if I had x squared to the third, that becomes x to the sixth. X to the a over x to the b, the powers subtract. So x to the second divided by x to the third would become x to the 2 minus 3, which is x to the negative 1. Anything to the 0 power is 1. Don't forget that. Super useful. And negative powers flip fractions. 1 over x to the a is the same thing as x to the negative a. So here I had x to the negative 1. That becomes 1 over x. If I had like x to the negative 6, that becomes 1 over x to the sixth. So negative powers flip fractions. We're going to take all of these properties right here and apply them in the exact same manner to problems like this that have fractions instead of whole numbers. So x to the 1/2 times x to the 5/2 is going to become x to the 1/2 plus 5/2. The powers add just like they did here. Well, these have a common denominator, so I can just add the numerators. I get x to the 6/2, and x to the 6/2 is actually just x to the third. Pretty sweet. And this one's going to become x to the 2/3 plus 1/4. Well, 2/3 and 1/4 need a common denominator. That number is 12. So I'm going to do 8/12 plus 3/12. So this becomes x to the 11/12. And don't forget, x to the 11/12 also means the 12th root of x to the 11th. How could we ever forget that? I think it's healthy to write it both ways for now. This, however, the powers don't add, the powers multiply. We're following this property right here. This will become x to the 2/3 times 3/4. Now multiplying is nice. You don't need a common denominator. This becomes x to the 6/12. X to the 6/12 is really just x to the 1/2, and x to the 1/2 is the square root of x. Okay, here we've got a negative power. Now I'm still going to be adding up these fractions. I'm going to have x to the 1/3 plus negative 4/5. So I could write that as just minus 4/5. It's really x to the 1/3 minus 4/5. I need a common denominator, which is 15. So it's 5/15 minus 12/15, which gives me x to the negative 7/15. Now x to the negative 7/15 I would write as 1 over x to the 7/15, because the negative power flips the fraction over. So it's 1 over x to the 7/15. And if you wanted to write that as the 15th root of x to the 7th, you could. That would be 1 over the 15th root of x to the 7th. You want to be very fluid, able to go back and forth between these two whenever it suits you, so that you can perform your operations in whatever way you find most convenient. I feel like I said the word convenient really well right there. Here the powers multiply. 1/3 times negative 2/3 becomes negative 2/9. So negative 2/9 would be 1 over b to the 2/9. A negative power just flips a fraction. Here the powers add. 4/5 minus 4/5 is just 0, and a to the 0 is 1. Anything to the 0 power is 1. So we're getting the idea here. All we're doing is the same properties of exponents, but just with fractions, as opposed to with whole numbers and integers. Subtract. 3/4 minus 1/4 is 2/4. 2/4 is a half. This is the square root of x. Subtract. 2/3 minus 3/5. It's a bad looking 3. I need a common denominator here. So it's going to be 15 again. 10/15 minus 9/15. This is going to be x to the 1/15. And this is going to become x to the quarter minus negative a quarter. I'm subtracting, but I'm subtracting a negative. So this becomes x to the 2/4, which is again x to the 1/2. Let's come up, what, 3 times now? Square root of x. Okay, properties of exponents with fractions. Rational powers make radicals. Good stuff. We're going to do some evaluating. Evaluate means just calculate the value. Okay, we're going to calculate the values of some things with all kinds of different powers. The key to these is understanding the base, right? The simplest version. Like for all these problems are much more doable if I can understand that 8 to the 1/3 is 2. 8 to the 1/3 is 2 because 1/3 power means the third root of 8, and the third root of 8 is 2 because 2 to the third is 8. So 8 to the 1/3 is 2. Well, since 8 to the 1/3 equals 2, 8 to the 2/3 I can think of as being 8 to the 1/3 squared, because of that property that we just talked about, how x to the a to the b equals x to the a times b. I can also turn that into like something like x to the 2/3 is the same as x to the 1/3 squared. Don't know why that's not, oh, I know why, okay. X to the 1/3 squared. I'll write it down here. So if I know that 8 to the 1/3 is 2, then 8 to the 2/3 is going to be 2 squared, which is 4. I could also think of it this way. You might like it better this way. I'm doing the cube root of 8 squared. That's how this converts. Well, I recommend you make numbers smaller before you make them bigger. The cube root of 8 is 2, and 2 squared is 4. So 8 to the negative 1/3. Well, since I know that 8 to the 1/3 is 2, 8 to the negative 1/3 is 1 over 2. It's a half. And 8 to the negative 2/3. Well, since I know that 8 to the positive 2/3 was 4, this is going to be 1 over 4, because the negative power just flips a fraction. Okay, so here's 8 to the 4/3. And again, if I'm going too fast, just pause, rewind, slow down, put me at 0.5 speed, whatever you need. 8 to the 4/3. You can think of this as 8 to the 1/3 to the 4th. And 8 to the 1/3 we know is 2, and 2 to the 4th we know is 16. And that's great. But what you might prefer is to think of 8 to the 4/3 as being the third root of 8 to the 4th. And we know the third root of 8 is 2, so 2 to the 4th is 16. I don't really care how you do it. Okay, I think we discussed this before, but I want to make sure. You can have odd roots of negative powers. The third root of negative 8 is negative 2. So negative 8 to the 1/3 is negative 2. And so negative 8 to the 2/3 is positive 4. Because we're squaring, right? Negative 8 to the 2/3 means do the third root of negative 8 and then square it. Well, the third root of negative 8 is negative 2, but negative 2 squared is positive 4. So we're going to have some homework problems and some practice problems that have us dealing with fairly simple base numbers, like 8 or 16 or 27 or 125 or something. And they're simple because they have obvious roots. If I want to find 16 to the 3/4, I can think of this as being the fourth root of 16 cubed. And the fourth root of 16 is 2. In fact, that's just worth me thinking about. Okay, 16 to the 1/4 is 2. So 2 to the third is 8. 16 to the 3/4 is 8. Well, then 16 to the negative 3/4 is 1 over 8. Flip it over. Negative 16 to the quarter is impossible. I can't do a fourth root of negative 16 because there's no number that when brought to the fourth power comes out to positive 16. It's always going to come out to negative 16. So even roots can't be negative. Odd roots can. I can do the third root of negative 27 because that's negative 3, but I can't do the fourth root of negative 64. That is not negative 4. You can do even roots if they're negative. You can do odd roots if they're negative. You can't do even roots if they're negative. Cool. Okay, lastly, we're going to move from talking strictly about fraction powers to talking about radicals, even though they're basically the same thing. If you have two radicals multiplying, multiply the stuff inside. That only works if their index is the same. So like the third root of 4 times the third root of 5 is the third root of 20. But the third root of 4 times the square root of 5 is not like anything useful right now. We can't do it, okay? They have to have the exact same type of root. If I had, a third root again, yeah, I'd have third root of 20, but I don't, so I don't. So root 6 times root 10 becomes root 60. I'm going to break down root 60. Here's a pair. The pair comes out. 5 and 3 stay behind, so it's 2 root 15. I'm going to multiply and simplify. We've learned how to do that before. If you need help with that, let me know. We can talk about it, but I don't want to spend time on it here. 12 times 10 is 120. There's going to be 3 x's. I don't know if we've spent as much time talking about simplifying these radicals. Okay, now I'm questioning if we've ever talked about simplifying radicals. So I'm going to go back and do this one a bit slower. And if you've learned how to simplify radicals, if you don't have a question about how to do that, then skip this. Okay, but I actually think it might be worth going over. Root 6 times root 10 is root 60. But I want to see if there's any perfect squares that I can pull out of root 60. So to do that, I make a factor tree. The factor tree shows me all the prime numbers that make up 60. So 60 is 2 times 2 times 3 times 5. What I'm looking for now are pairs, groups of 2 of the same number, because 2 times 2 is really 4, and I can square root 4. The square root of 4 is 2, so the 2 comes out. So this becomes 2 root 15. So here, this becomes 120x to the third. But 120 can break down. It's 12 and 10. 12 is 6 and 2. 6 is 2 and 3. 10 is 2 and 5. So this is really, I'll do it over here, 2 times 2 times 2 times 3 times 5. Here is a pair of 2's. I can pull out a pair of 2's. So a pair of 2's comes out. It's just a 2 now. And what's left behind is a 2 times 3 times 5, which is 30. So root 120 is the same thing as 2 root 30. But I still have to deal with the x's, right? I have 3 x's I have to deal with. Well, since I have 3 x's, there's a pair. So x to the third is really the same as x root x, because a pair comes out and 1 stays behind. So if I combine these two things together, I get 2x square root 30x. So that is how all that simplifies. I'm going to erase all this. Grab this and pull it over here. Okay, I'm going to type come back for anybody who is zooming forward. Come back now. We're going to do the same thing with cube roots instead of square roots. The game doesn't really change. I'm just looking for groups of 3 instead of groups of 2. So when I multiply all this, I'm going to get the third root of 24x to the 5th. No, x to the 7th. There's 5 and 2. I misread that. I thought it was 3 and 2. Well, 24 is 8 and 3. 8 is 4 and 2. 4 is 2 and 2. Here's a triple. There's my 3 of a kind. I need groups of 3 instead of groups of 2 because I'm doing a cube root. So the triple comes out. The 3 stays behind. Now let's look at the x's, right? I have 7 x's to worry about. Here's the fastest way to deal with variables that have powers. Take the variable power, take the 7, divide it by the number on the shelf, which is 3. 7 divided by 3 is 2, remainder 1. Right? 7 divided by 3 is 2, it'll get you 6, there's 1 left over for 7. Well, that means that 2 x's come out, remainder 1x, 1x remains behind. So this will be written as 2x squared times the third root of 3x. Okay, so take the power on the variable, divide it by the number on the shelf, the remainder stays home. So this becomes 20 times 15 is 300, I think. There are 3 x's and there are 9 y's. 300 can break down pretty simply. It's 10 root 3. Okay, it's just 10 root 3. I think we should be okay with seeing that. If I take this power of 3 and divide it by the number on the shelf, and the number on the shelf is a 2, 3 divided by 2 is 1, remainder 1. So 1x comes out, 1x stays in. If I take this power and divide it by 2, 9 divided by 2 is 4, remainder 1. So 4 y's come out, and 1 y stays behind. This is how it simplifies. Now that might not look much simpler, 10xy to the 4th, but it's going to be easier to work with as we move forward. Trust me, we like it simplified. Okay, we've got 3 more and then we're done. So stay with me. 128. I'm doing a 5th root. I need groups of 5. Oh boy. 128 is 2 and 64. 64 is 2 and 32. 32 is 2 and 16. 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. Here's 1, 2, 3, 4, 5 2's. Here's a group of 5 2's that I'm going to pull out. 2 2 stayed behind. Now I'm going to take the power 12. 12 divided by 5 is 2, remainder 2. So I have 2x squared with 2x's staying behind. There's my simplified form. Okay, this next one here is really straightforward. When you have a bunch of radicals with fractions, they can still just multiply across the top and across the bottom like you have regular fractions. This can become 120 over whatever 27 times 8 is. I kind of don't want to do 27 times 8 because I can do some simplifying first. Like before I do the multiplying, I can do some cross-canceling. 6 and 27 can both divide by 3. 8 and 20 can both divide by 4. So I could actually, and then the 2's can cancel right here. This is actually just 5 over 9. And then, this is sort of crazy, right? I can make this 2 different radicals. That's one of the properties of radicals. And the square root of 9 is just 3. This becomes root 5 over 3. I can square root the 9 on the bottom, but still have the 5 on top inside the radical. I square root the 9, but not the 5. Last one is this. When these multiply, it becomes x squared minus 16. Because x minus 4 times x plus 4 is a difference of squares and things cancel. You get x squared minus 4x plus 4x minus 16. But I want to make this super, super clear. X squared minus 16 is not the same as x minus 4 or x plus 4. It is not the same as the square root of x squared minus the square root of 16. You can't take a big radical with addition or subtraction and split it up. You can split up a radical with multiplication or division, like I did here. Or like if I had this, if I wanted to, I could turn it into this. With multiplication, you can split up radicals, not with addition or subtraction, so don't try to do this. Just leave it x squared minus 16. Okay, thanks. We did it. See you next time.